All right, here's our bell work. More solving equations kind of stuff, which is, of course, what we're going to be doing today. So there's our bell work, and we'll solve it with principles of equality. Of course, first we'd look to see if there's any distribution first, but there's no parentheses here, so we don't need any distribution. And I don't see any combining of like terms. And do be careful, one of the things we saw in that last quiz was students were combining these 3x's with these negative 12x's. But remember, they're on opposite sides of the equal sign, so we need to break them up. That's what this whole upside down T strategy is for, okay? So now that we have this, no distribution, no combining like terms, we just got to kind of choose a side for the x's and the numbers up here. And you've seen that in the past, I usually put the x's on the left and numbers on the right. That's because most students will just maintain that strategy, okay? And then we go through each term, determining if it's on the correct side or not. And if it's not, then we zero that out, which, remember, that would include the addition or subtraction principles of equality. So 3x, yeah, that's an x term, so it's on the correct side. See, we're looking at this side of the line, which is the x side, so that one stays. But the plus 5, yeah, that one is not an x term, doesn't have an x. So I'm going to have to zero that out by subtracting 5. But if I do it to one side, I got to do it to both sides like this, okay? So that will zero that out just like we want. I'll drop my 3x, which now equals 14 minus 5, which is 9. And then I'll drop this negative 12x. Remember, it reads minus 12x, but it's actually a term of negative 12x. And then scanning again, right, we already know the 3x is on the correct side. The 9 is on the correct side because it's a number by itself. And then the negative 12x, yeah, that's on the number side of things, so that has to go as well. And by that has to go, I mean, got to change that into a zero term so we can ignore it, right? So negative 12x's, I'll make 0 by adding 12x's. It's just, if I do it to one side, I got to do it the other side as well. Okay, so 3x's plus 12x's would be 15x's. And then this will equal the 9, which I'll drop. And then the negative 12x's plus 12x's zeroes out. Now that we got this, we have one term on one side, one term on the other. It's an x term equals a number. Last thing we got to do is change that coefficient of x into a 1. So I'll just divide both sides by 15. And that makes the coefficient of x a phantom 1. X equals 9/15. I would put that in the calculator. It'll simplify for you as 3/5. So the last thing we want to do with all the equations we solve is just replace x with 3/5 and just check for truthfulness. So there's only 2 x's to replace, and I go to the calculator to check for truthfulness here. In my calculator, just on the left side, I got 34/5. Well, let's see on the right side. Yep, putting that in the calculator, I also got 34/5. So that tells us that this equation is true when we replace x with 3/5. So I know it's the solution. Here's our objective. I can solve equations for a specific variable. And this objective, maybe I should have included that we're still going to be using principles of equality, but yeah, we're not solving a variable for a number anymore. We're solving for what will look like an expression. That's going to feel weird at first, but hopefully we can get used to it so that we just understand that the principles of equality are good. No matter if you're working with numbers or letter terms, doesn't matter, they always work. So take 30 seconds and copy that down, please. So what is the solution? Remember that it's usually a value that we can replace the letter with to make it true. It's just, again, in this section, we're not actually replacing letters with numbers. We're going to be replacing them with expressions. So that's what your answer is going to look like, is expressions. But again, we are applying the principles of equality throughout this process. So as long as you understand what we've been doing, whatever you do to one side, you got to do the other side. That's principles of equality. If you can just understand that, then there's no limit to how much of this type of math you can do. And it really opens the doors to you to be able to do not just this type of algebra, but algebra 2, trig, and pretty much all the way up to calculus. If you can just get this skill down and understand that it still applies no matter what the equation may look like. So yeah, there's our principles of equality. Remember, though, that the idea will still remain. We use addition and subtraction principles of equality to make 0. zeros. And then multiplication and division is to make ones. And now, it'll still be associated with the coefficient of the value we're trying to solve, but it's always for coefficients, okay? Now, it does go in that order, just like we saw in the bell work. You make zeros, and then at the very end, that's when you make ones. And usually you only have to do it once, because in order to make one, you can just divide both sides by the coefficient pretty much, and then you're done. So, and then that's probably why you haven't seen us use multiplication principle of equality too much, unless it was something like, and I think we've seen this x over, what was it, like 3.6 equals 4.9. Right, then you say you multiply both sides by 3.6. That's the multiplication principle of equality. It's really to make that denominator one more than anything. All right, now a lot of times, this is a nice intro to solving equations that have no numbers. And some students kind of get thrown off by this. There are numbers, by the way, you just can't see them, which means they are phantom values. In fact, if we needed to, we could say, look at this plus 0 right here. It was there the whole time, lurking in the shadows, hiding, ever watching, but we just don't really want that there, okay? The values I'm talking about are phantom ones like this. Okay, it's just, well, we need those phantom ones. No, we won't, okay? Again, our answers, for the most part, are going to look more like expressions than anything. Oh yeah, there we go. It says solve for m. Now, when it says solve for a letter, like it does right there, it's telling us in the end you should get m equals, and then whatever it equals may look like garbage to us right now because we're just used to seeing, hey, m equals 5, and then it's like, that feels pretty good inside, right? But now it may look not like m equals 5. It may look like more than just a number or even just one letter, okay? Now, what this means is if they said solve for p instead of m, this would be done. Right there, p equals v minus m. But we want to solve for m, okay? So that means that m needs to be by itself, right? We want a phantom coefficient of 1. And we don't want anything else added or subtracted to it. So right now, I got this v positive combining, really be adding with this negative m. So I got to get rid of that. And again, by get rid of, I'm talking about making it a 0. Okay, so the v here, I'm going to go ahead and subtract it, but from both sides. Now, I purposely put this minus v on the left under the p because most students will do that. However, what we should remember here is that these two, the p term and the v term, they are not like terms 2 combined. So you couldn't say, well, p minus v is like a negative pv. No, that's a multiplication problem. This is subtraction, okay? This is the subtraction principle of equality. So it really ends up being p minus v like this, okay? Well, that's kind of funky, but it is possible to do because I've just applied the principle of equality, the subtraction principle of equality, to my v's in order to make this work, okay? Because remember, the objective right now with this problem is to make it m equals. Now in doing so, we did zero out the v right there, which was part of the objective, but we still have to drop this negative m right there, okay? But notice, when we solve for m, we do not want it to be a negative m. I mean, really it's a negative 1m right there, by the way. So if you need to see that phantom 1, then show it. I don't want negative 1m. I just want a 1m that I can make a phantom 1. So how do I get rid of a negative 1m? That's a coefficient, which means I'm going to have to go into my division principle of equality. So I will divide that negative 1 by negative 1. Which, if I do, that means that I got to divide all the terms by negative 1. So see this one? Got to divide it by negative 1, which may be a good time to show that phantom negative 1v. But also, I'd have to divide the p by, well, negative 1, okay? So maybe it's good to see that p like this. Well, if that's the case, what happens to our values? Well, the p remains a p and the v remains a v, But what happens to their coefficients? They pretty much just switch signs at this point. So 1 divided by -1 for the coefficient of p, that's going to be -1p. And then the -1 coefficient of v divided by -1 is a +1. So that's a +1b. And then this would equal, -1 divided by -1 is +1. So now I can just write this out as just m. Okay, now if I wanted to simplify this, I could just say m equals -p plus v, if I wanted. And I would say that's more simplified. In fact, on Canvas, I believe that's the way you would want it shown. Now, that's one way to do this. And these two methods right here aren't too different, but I'm looking back here, this part of the equation, right, where we had p minus v equals -m, like this. So another way to do this is essentially just to divide both entire sides by -1, because that'll make that a phantom 1, so you get m equals. And then, again, you'd look at both of the coefficients. Dividing by -1 just changes the signs. So where the p was positive, it's negative. Where the v was negative, it's now positive. Okay. See how you get the same answer, it's just shown in a different way. But again, it's just applying principles of equality strictly to letters, pretty much, instead of just having numbers. And again, this is the final answer right here. And what this does for us is it allows us to take formulas that exist everywhere and reconfigure them to do what we want them to do, okay? So it's about you taking control of the equation through principles of equality rather than them taking control of you, because they will. They will, or other people will just control your brains with them. But again, we want them to serve our purposes, not the other way around. J equals xk, and this one says to solve for x right here, no problem. Okay, so in the end, what I would really like here is just x equals, and I'm purposely putting the x on the right side here because it's already on the right side of the equal sign, okay? So this k right here, I got to get rid of that. Now this is a division part right there. Remember that fraction line represents division. So if I want to get rid of it, that k, that means I need to change it into a phantom 1 with multiplication. It's just, if you do it to one side, make sure you do it to the other side as well. So on the left side, I got k times j equals, well, the k's, yeah, they become a phantom 1 right there through some fraction multiplication. But it's okay just to say that they become a phantom 1. And that's it. That does it right there. X equals kj. Again, this is, well, I'm showing the multiplication there. I probably wouldn't. But this may not be what we're used to, but it needs to be something that we can do. Yeah, so again, you got to get used to how unusual this is because you're going to see it quite often in the future. Well, here's an interesting one. It's kind of a bigger form of the one we just saw. Maybe it's combined a little bit with the first one we did. But in any case, it's doable. All right? So we look at this one, and it says to solve for t. So again, this means that in the end, I'm targeting this variable right here. And in the end, I just want it to be t equals something. I don't want anything added to the t like we see here. I don't want anything divided by the t like we see here. I don't want any of that stuff. So what I'll have to do is I kind of just want the numerator by itself. I don't want that divided by y. And that's usually just because it's that divide by y. We don't like fractions, so we want to get rid of that stuff. And remember, the fraction line itself is division. So if I want to get rid of the division, I'll have to use some multiplication. So I'm going to multiply both sides by y here to make that a phantom 1, which then leaves me with 9j plus t. So see how this gets me a little bit closer to just t equals. So y times rk, I'm just going to show that as y rk. So y times r times k equals 9 times j plus t. All right. Now, remember, I just got rid of the division with t, right there, or you could say this t expression. But I don't want the 9j being added to it either. I don't want that there. Now, this is with addition. So again, it's a matter of choosing the correct principle of equality here. I don't like that 9j there, so I'm going to have to zero that one out because it is addition. And so to get rid of it, I will have to use subtraction. That's a positive 9j. I'm going to make it a 0 by subtracting 9j from both sides. Now I'm doing this on purpose here. I'm purposely placing the 9j, negative 9j, away from this term y times r times k. And that's because they're not like terms that I can combine. Okay, so, well, why did we able to combine the y with the rk? Because it was multiplication. But this is subtraction, right? So now may be a good time to show that the y was positive, or that whole term was positive. And now, what do we get? Well, I'd have negative 9j. Again, it's not a like term that I can combine with positive yrk. But this then equals, see this 9j that we had in black? It zeroed out that negative 9j in purple, and I can just drop the t. As it turns out, this is done. Yeah, if I had placed that a little bit differently, so this is what it would look like. You can put the yrk term first, but then it would be minus 9j, because it's, yeah, so, and then this would equal t. So both of these are correct, by the way. Either one of these would work. But again, with as much solving equations we've done, where it's like, hey, m equals 5 or x equals negative 10, this is usually, or it feels very unusual. Either one of these would. But they're both correct because we have used principles of equality. Remember, the whole idea with principles of equality is that they maintain equality throughout the problem. So this maintains equality. It just changes what we would solve for in this case. In this case, t, whatever it represents. All right, solve for x on this one. That's what we're kind of used to. But again, we're usually used to seeing x equals something. But this time, it's going to be, it'll be x equals something, but it'll be kind of ugly compared to what we've seen. So how am I going to solve for x? Well, I see x is in the numerator there, so I don't want this divided by 10k, which means that I'm going to have to take that 10k and multiply it on both sides. Okay, so multiply by 10k here. If I do it to one side, I got to do it to the other side as well. So again, that will become a phantom 1, 10k in the denominator. And I'll take my numerator and pretty much drop it. Again, there's still a divide by 1 phantom value here. I just don't want to show it because it doesn't help us out. And then on the left, I would have 10 times k times g. And that would equal xa plus 4. So we're pretty close. We're pretty close here, right? In the end, we just want this to be x equal. So that plus 4, I don't want anything added or subtracted to my x term. And you could think of a as a number. Right? If this was 5x plus 4, you'd probably know to subtract 4 from both sides. So that's what we need to do next. So I'm going to show subtract 4 here. And then I'm kind of purposely offsetting that with 10 kg, which is not meant to be kilograms, by the way. So what do I get on the left? Well, you drop your 10 kg, and then the minus 4, again, it gets dropped as well because there was no like terms to combine it with. And then this would equal xa, yeah, just drop it. And then the positive 4 minus 4, that zeroed out just like we wanted it to. So now I've got something multiplied by x. Even though it's not in front of the x, it's behind it, it's still being multiplied. So it'd be like saying you got x times 5. The process is still the same as though it were in front. We're going to divide both sides by the coefficient. Remember, coefficient is a letter or number, I guess, being multiplied by letter. In this case, the a is being multiplied by x, so I want to divide both sides by a. I do want to show it like this. I believe on the homework it wants to show more like this right here. So I'll phantom 1 that a right there, and I'm left then with just x equals, well, everything there on the left. So this stuff. Okay, so x equals 10 kg, that's 10 times k times g minus 4 all over a. How will you show that in the homework? You'll have to put this in parentheses, and then you'll put a slash a. So if you were typing this into the homework, it'll look something a little bit more like this. Again, you'd need the parentheses. You'd type 10 kg. That's a lowercase k, by the way. My k's just kind of suck. And then minus 4. And then you do the slash a. And that's how you'd have to type that into the homework. So the reason why that is because there's an order of operations problem, and Canvas doesn't know the difference if you just type 10 kg minus 4. it would read this, if you didn't have the parentheses there, it would think you want just 4 divided by a, not the whole expression there. On this one, we want to solve for a. Now, I don't see anything like divided by the whole side here. So I want to get rid of anything being added or subtracted. So I'm talking about the C and the B right there. So you can do these both at once, by the way. You can say, well, I'm going to subtract C from both sides. And again, I'm kind of purposely offsetting that. And then the B as well, I would want to zero that out. So, well, you could do this in 2 steps. I can just do it like this, okay? So what does that do for us? Well, it's going to isolate my A term, right? Because the C's will zero out. I'll drop my 2 times V times A, which is positive. And then my B term also zeroes out, just like I wanted. So then I'll drop my MG term. And I got minus C and also minus B. But with my A, I don't want the 2 or the V being multiplied with it. So I would want to make those phantom values. Since it's multiplication, I will have to use division to make those phantom 1s. So that's what I will do. I will divide not just by 2, but 2V. If I do it to one side, I'll do it to the other side as well. 2V divided by 2V, that's a phantom 1, just like we want, which leaves me with just the A equals, well, everything here on the right. There it is. Now again, on the homework, you'll have to write it, you'll have to type it out like this, okay, because we want the whole numerator together. You don't have to type A equals, you're just going to have to put mg, you'll type mg minus c minus b, but you'll need that in parentheses, and then you'll put your slash sign, and then right here, if you had 2 values in the denominator, you'd need that in parentheses as well, okay? Again, that's an order of operations things, and if you don't tell the computer to put it with the order of operations, it will think you mean something very, very different. All right, how about this one? What's this? Solve for G. I guess it's done. If it was asking that. I'm going to change this to make it a little bit more. I want to take this to the limit, right? So I'm not going to solve for G. I'm going to solve for the letter that looks like G. I assume that's a typo. And I'm going to solve for Y instead. Okay? Let's go back and solve for Y. All right. Well, if I'm solving for Y, I don't want anything added or subtracted to it. So when I put my principles of equality down, I don't want that minus 3 with it. So I would have to add 3, which again, I'm going to kind of purposely offset over there. It's plus 3 right there. The G is positive, and I'm going to need that when I drop that down to show it as plus G. And then the positive 12x, yeah, I don't want that there either. So I'm going to subtract 12x from both sides as well. Now I'm just going to show that as negative 12x. So what happens? Well, my negative 12x in purple just stays negative 12x. The positive 3 stays positive 3. And then the positive G also, even if you hadn't shown the positive sign now, you'll need it because it's not 3 times G, it's 3 plus G. Yeah, and so yeah, that's a great question, because if I change the order here, it's not going to change the value of this expression. It just changes the way it looks. You could do 3 plus G minus 12x, G plus 3 minus 12x, however you want that, yep. Just make sure it's simplified. You wouldn't want to put plus negative 12x. Now, what does this do on the right side? Well, like we said before, we kind of want to isolate those y's, so we wanted them by themselves. We didn't want anything added or subtracted to the y's. That's what we've done by dropping that 2y. The negative 3 plus 3 is 0, and then 12x is minus 12x is also zeros out, just like we wanted. But then, remember, we're solving for y, so I don't want anything multiplied by the y like that 2. So I'm going to make that a phantom 1 by dividing it by 2. So just if I do it to one side, I will do it to the other side as well. That makes that a phantom 1, and I get y equals, well, this garbage. Oh, there it is. Okay. I just want to emphasize this because I don't want you to lose credit because you're typing things in wrong, especially if it's correct, okay? Remember the whole denominator here, you're going to have to put in parentheses. So you're going to open a set of parentheses, type in your negative 12x plus 3 plus G. Remember, the order doesn't matter. And if I remember right, it won't matter on the homework. And then you'll divide this all by 2. Okay, remember you have to divide the whole thing by 2 right here. So that's why we show divide by 2 like that. So when you type this in, it should look pretty much like this. All right, here we got y divided by x equals a divided by b. Solve for y. Yeah, that's a good one. I guess take 30 seconds to try this one out, okay? Then we'll go over it. All right, hopefully that was enough time. We are solving for y. So in this is a proportion, by the way. And I usually like to solve proportions with fish method, but no need for it on this one. Because, remember this fraction line with the y. I'm looking at the y specifically because that's what we're solving for. That's division. It's divide by x. I don't want to divide by x. I just want it to be y. I want it to be y equals. So it's so close, I just got to get rid of that divide by x by multiplying both sides by x, okay? Now what does this do on the right side? Well, actually, what does it do on the left side? Well, it makes that a phantom 1x. It makes a phantom 1 out of the x's. So I end up with just y, which is good. Well, what happens to this x right here? Because it is possible to say, look, I'm just going to show this as a over b times x, like this. But on Canvas, it wouldn't want it like that. So here's what we're going to do, okay? I'm going to show a lot more steps than you'd need on this. The shortcut here is just to say, look, you take your fraction a over b. The x is part of the numerator. So it's really a times x divided by b. Having seen that, though, here's why that works. Is because it's really x over 1, and that's fraction multiplication. A times x is ax. B times 1. You wouldn't want to show the 1. You just want the b right there. Okay, so again, I showed a lot more work there, even though it wasn't very much. But it's a lot more work than you'd need to when solving this. So what does this mean for us in this problem? If you were to type this into Canvas, you'd still want the ax in parentheses and then slash b like this. So here's our objective again. I can solve equations for a specific variable. There we go.